Hi, welcome back to the second segment of the lecture, where we'll talk about running the independent samples t-test in our studio and interpret it. So let's take a look at this demo. So we're using the sleep dataset, and here's the research question. Do students who are reporting elevated symptoms of anxiety report more difficulty sleeping compared to those that are reporting normal levels of anxiety? And so it stands to reason that if you feel anxious, maybe you have more trouble sleeping. And so the data were collected from 273 college students, and they provided ratings of anxiety and insomnia symptoms. And those ratings were converted into these two variables. And so first of all, the variable anxious categorized the students into groups that said, yes, I have elevated anxiety, and no, I do not have elevated anxiety. And then there's also the variable sleep 2, which talked about sleep difficulties measured at time 2, so second time point. So here is the independent variable, which is a categorical variable with 2 levels. And then here is a dependent variable, which is a continuous variable that you're comparing those 2 groups on, anxious and not anxious. Converting that into hypotheses, here is an example of a two-tailed hypothesis, where you're just saying there is a difference between those 2 groups on sleep difficulties versus not, which is a null hypothesis. Now we're going to test a one-tailed hypothesis that says that there's a difference in sleep difficulties, so that those without anxiety score lower than those with anxiety. And so those with anxiety score higher. And a null hypothesis says the exact opposite, that those without anxiety do not score lower. And so this could actually mean that there's no difference between the 2 groups, or that those without anxiety actually score higher in sleep difficulties. So essentially not the alternate hypothesis is the null hypothesis. Now there's a reason why I wrote my alternate hypothesis like this, where I say those without anxiety score lower. You see more why I did this when we get to the RStudio code. Now just to give you a preview, what we're going to do is to run the t-test using the t.test function. Pretty easy to remember, right? And I've written out the form and what goes into the parentheses here. And so breaking this down, here's a dependent variable, regressed on essentially, right? IV, independent variable. And then depending on the results of the Levine's test, you can tell RStudio whether or not the variances are equal or not. And so you can write down true if the homogeneity of variance assumption is met, and then you can write down false, all caps, if homogeneity of variance assumption is violated. When you're running a one-tailed test, you can also use the alternative statement, which you've already used before. And so less means that group 1 has a lower mean than group 2. Greater would mean that the group 1 has a higher mean than group 2. And once you run the t-test like this and save that into an object, and so on the left-hand side you should see an object name with an arrow or the equal sign, and then print that destination object in order to get the t-test results. And so let's hop on over to RStudio and take a look to see how all of this works. Alright, so here we are in RStudio. Welcome, welcome. And what I've already done is to set my working directory. And so I highly recommend that you try to save it onto your hard drive in a folder that is easy to organize. And so in this case, I have just used my reference notebook, which makes my life easier because everything I need is in one folder. And I've also taken the liberty to read in the sleep data. And so there are 6 variables, and you will see their characteristics here. And so we're working with anxious, which take on the value of no versus yes, and sleepy 2, which is the dependent variable. And I've attached the dataset. And so first we want to check for the homogeneity of variance. And so is this assumption met? And you might remember the var.test slide that I showed you. And so now you want to say sleepy 2 is the dependent variable, and then anxious is the independent variable. And I've just called it Levine sleep 2, but you can call it whatever you'd like. And so I would run it and then ask to print it. So the p-value is 0.6571, certainly greater than 0.05, and so we retain the null hypothesis that says that the variances are equal between the two groups, anxious yes or no. And so we can proceed without worrying about making any adjustments. And so now it's time to run the independent samples t-test. Now let's call it t-test anx. You can certainly name the object the way you'd like, and we will use the t-test function. And now you might remember the same format as what you see above, which is that you essentially kind of regress the dv on iv, which is anxious. And then you might remember the var.equal statement, which is true because the Levene's test told us that the homogeneity of variance assumption is met. And now we have to come up with the alternative statement because now we're testing for one-tailed hypothesis. Now this is good, but now we have to figure out whether to put in less or greater. Now in order to do that, you have to figure out what our studio considers group 1 versus group 2. And so let's try to figure that out real quick. One way that I might do that is to just run a table or an xtabs, whichever you like. And in this case, I might do anxious, and it says no and yes. And so this is group 1, no, and then group 2 is yes. And so now we want to figure out what we're trying to say. Now we want to say that the dependent variable is going to be greater for yes and less for no. And so in this case, we want to say that the first group is going to score less, lower mean, than the second group, which is yes. And so that's how we would arrive at the alternative statement. So let's try running it. Okay, and then let's print it. Ta-da! And so here is a two-sample t-test, or the independent samples t-test. And it is testing the alternate hypothesis that the true difference in means between group no and group yes is less than 0. Group no is scoring less than group yes, which is reflected in the sample estimates here, where they tell you the mean score for sleepy 2 for the group that has the value of no for anxious, and the group that has yes for anxious right here. The t-value is here, along with the degrees of freedom, and then the p-value is very, very small. And so it looks like we would reject the null hypothesis. So let's talk about the results in detail and how to write it up. And so here is what we had in the two-sample test. And really, you're reading this part of the output for the main information for your t-test. And again, as I've mentioned before, the mean is shown here. And so focusing on this particular detail, you will notice that the p-value is very small. And so certainly smaller than 0.05, which means that you reject the null hypothesis. Now, what was the alternate hypothesis? The alternate hypothesis written up here for you, where the true difference in means between the first group, group no, and group yes, the second group, is less than 0. Translated, it really means the mean of no group is less than the mean of yes group. And that is consistent with what we see here. And so what we're saying is that the t-test suggests that there's a significant difference between the two groups and in the direction that we hypothesized. And so here is an example of a write-up. And so students with elevated anxiety reported significantly higher levels of sleep problems than those without elevated anxiety. And then in italics, lowercase t, and without any space, you start stating the degrees of freedom in parentheses. Now, the degrees of freedom is given to you by RStudio, but in case you want to calculate it, it's n-2. And then here is the t-value, and then the very small p-value. Now, you may be wondering, it kind of looks awkward like this because our alternate hypothesis we gave RStudio was in the other direction, where we're saying that the no group is less than, so lower than, the yes group for anxiety. And so if you wanted to rewrite it, here's an alternate statement that you could do. It's the same thing. Students reporting normative levels of anxiety, so those falling into the no category for anxious variable reported significantly lower levels of sleep problems compared to those with elevated anxiety, and then you can report the statistics there. And so either is fine. Now there's one more thing that I didn't get a chance to show you in our studio, so let me hop on over there and then meet you right back. Now you may be wondering, what if you don't have equal variances? And so the assumption of homogeneous variance is violated. So you saw a small p-value when you ran the Levene's test. So let me show you what it looks like if you were to run it that way. I'm going to just rename the model with a different name and replace the true statement with false and then try to run the same thing. So what if we didn't meet the assumption of homogeneity? Then you would switch the var.equal equals statement to false, and then let me run it for you. And then print the object. And what it does is to make some adjustments. So now instead of saying 2-sample t-test, which is what it's run when you can assume equal variances, when you can't assume that, then it runs Welch's 2-sample t-test. And so it's made some adjustments so you can see the degrees of freedom is adjusted and so on. But the p-value, once again, is very, very small. And so you will see Welch's 2-sample t-test. If you say that the homogeneous variance is not there, false. Var equals false. And if you say that there's homogeneous variance, then you will see a result that says 2-sample t-test. In this case, we can just interpret this part. All right, welcome back, my friends. And so now it is your turn to run your independent samples t-test. And so once again, using the sleep.xlx dataset, please test the following research question. Do students in a romantic relationship, so there's a relationship variable, report more sleep difficulties, sleepy 2 again, compared to those not in a romantic relationship? And so the two variables you need are relationship, which indicates whether or not the person is in a relationship, yes or no. And then there's our trusty friend, sleepy 2, sleep difficulties at time 2. And this is just a friendly reminder to do your legwork and make sure to select the correct options for var.equal and alternative statements. And so good luck and enjoy. And hope you have a great day. I'll talk to you soon. Take care for now.